Hello out there, welcome to this tutorial on polynomials. In this video, we'll be looking at miscellaneous problems 1. This is part 1 of the miscellaneous problem. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on polynomials. So we start the first problem. Given that x plus 1 all squared is a factor of f of x equal to x cubed plus mx squared plus nx plus 3, find the value of m and of n. Hence, find the zeros of f of x. This is another polynomial. We are given two factors and we need the third factor. Two factors are given here. We need the third factor. So to solve this problem, we will let x plus b be the third factor. Having gotten the third factor, we say x cubed plus mx squared plus nx plus 3 is equal to x plus b into x plus 1 into x plus 1. Since x plus 1 is squared, so we split it into x plus 1 into x plus 1. Then we expand and compare the coefficients. So in our expansion, we have x plus b into, expanding this, we have x squared plus 2x plus 1. Then also, we now expand it finally. So to expand this, we use this x to multiply every term in the second bracket. So x times x squared gives x cubed, x times 2x gives 2x squared, x times 1 gives x. We then use b to multiply every term in the second bracket. So we have b times x squared gives plus bx squared, b times 2x gives 2bx, and b times 1 gives b. So we then simplify. In our simplification, we have x cubed 2x squared plus bx squared will give us 2 plus b into x squared. Then x plus 2bx will give plus 2b plus 1 into x, then plus b. If we now compare the left hand side and the right hand side, it is very clear then that b is equal to 3. Very clear. So because the constant term here is 3 and the constant term here is also b. So b is equal to 3. Then we compare the coefficient of x cubed, which is 1, and we don't have any business with that. And here the coefficient of x squared is m, and here the coefficient is 2 plus b. So we now have m is equal to 5, since 2 plus 3 gives 5. And also 2b plus 1 is the coefficient of x here, where n is the coefficient of x here, which gives n is equal to 2 times 3 gives 6 plus 1, 7. N is equal to 7. So now that we've gotten the values of m and n, we can now go ahead to find the zeros of the polynomial f of x. So the zeros now will be, since we've gotten the third factor to be x plus 3, so we have it as x plus 3 into x plus 1, x plus 1 is equal to 0. So which means x is equal to negative 3 and x is equal to negative 1 twice. And that's the end of solution to problem 1. Then we go to problem 2. For problem 2, we have A, show that x minus 1 is a factor of f of x equal to x cubed minus 3x squared plus 7x minus 5. B, find the other factor. C. Show that f of x has only one real root. We are given a factor. We are to look for the second factor. And since we are going to make use of the second factor, what we do is we go by long division. So we are going to show that x minus 1 is a factor of this. If we divide the polynomial by x minus 1 and it gives 0, then it is a factor. So the quotient now will give us the second factor. We then use the two factors now to verify the C. So we start with A by long algebraic division. So the polynomial will be inside and the divisor will be x minus 1. You still remember x cubed divided by x gives x squared. Then we now use the x squared to multiply the divisor. So x squared times x gives x cubed. X squared times negative 1 gives negative x squared. We then subtract x cubed minus x cubed. That one is gone. Minus 3x squared minus negative x squared. So negative here gives positive. So we have minus 3x squared plus x squared, which gives minus 2x squared. We then bring down the 7x. After bringing 7x, we now concentrate on the first term here. Minus 2x squared divided by x will give us negative 2x. We use the negative 2x to multiply every term in the divisor. Minus 2x multiplied by x gives negative 2x squared. Negative 2x multiplied by negative 1 gives positive 2x. Then we subtract. So these first terms are gone. 7x minus 2x gives 5x. We then bring down the constant, which is negative 5. So we have 5x minus 5 as our dividend now. So 5x divided by x gives plus 5. And 5 times x gives 5x. 5 times negative 1 gives negative 5. Subtracting, we have our remainder as 0. We then conclude that x minus 1 is a factor of f of x. That has been shown. Then for B, so we have to find the other factor, and the other factor is the quotient we have here, which is x squared minus 2x plus 5. Then we go ahead to show that the polynomial f of x has only one real root. So in our solution there, we are going to equate the polynomial to 0. Since this is a factor, we have x minus 1. The other factor is x squared minus 2x plus 5 is equal to 0. So x minus 1 is equal to 0 and x squared minus 2x plus 5 is equal to 0. So we see that x is equal to 1 is the real root. We now verify. What are we verifying? Is b squared minus 4ac less than 0 from the second factor? So what is our a? Our a is 1, our b is negative 2, and c is 5. We substitute into this. If it gives a negative number, then the roots of this quadratic equation, which is a factor of the polynomial f of x, will now have complex roots. So we substitute. We have negative 2 squared minus 4 times 1 then times 5. Negative 2 squared is 4, and 4 times 1 times 5 gives 20, so we have minus 20. 4 minus 20 gives negative 16, and negative 16 is less than 0. Therefore, the only real root is x equal to 1. So the other roots are complex. So that's the end of solution to problem 2. we go to problem 3. For problem 3, given that h of x is equal to x cubed plus 3x squared plus 3bx minus 2b squared is exactly divisible by x plus b, and b is less than 0, that is negative, find the value of b and hence factorize h of x completely. In our solution here, so we're going to apply remainder theorem. Since x plus b is a factor of h of x, we'll equate this to 0, which means x is equal to negative b. So by remainders theorem, it means h of negative b is going to be 0. So to get h of negative b, wherever we see x, we put negative b. Negative b cubed will give us negative b cubed, and negative b squared gives b squared, so we have plus 3b squared, and here this is going to be 3 times b times negative b, that will give us negative 3b squared, and then minus 2b squared, and this is equal to 0. And if you look at this, 3b squared minus 3b squared, the middle terms here are gone. We are now left with minus b cubed minus 2b squared is equal to 0, and the negative signs can be removed if you divide through by negative 1. So to find b now, we factorize. We have b squared is a factor, so we have b squared into b plus 2 equals 0. Since b is less than 0 and it's not equal to 0, we are not concerned about b plus 2 to be equal to 0. We forget about b squared equals 0. We now see b is equal to negative 2. And that is the first part. We have gotten b. We now substitute in b into the original polynomial. So we have h of x will be equal to x3 plus 3x squared minus 6x. Since b is negative 2 times 3 gives negative 6, then x. That's how we got minus 6x. And here minus 2b squared. Negative 2 squared is 4 times negative 2 gives negative 8. So this is the original polynomial h of x. Then we are now to factorize completely. This also means x minus 2 is a factor of h of x. So having gotten that, we are going to embark on long algebraic division. The h of x is inside here and the divisor is x minus 2. Then here we say x cubed divided by x gives x squared. X squared times x gives x cubed. X squared times negative 2 gives negative 2x squared. We subtract. So our subtraction, we are going to have 5x squared. We then bring down the minus 6x. So 5x squared divided by x gives plus 5x. Now 5x times x gives 5x squared. Then 5x times negative 2 gives negative 10x. We then subtract. In our subtraction, this one is gone. This is going to give us 4x. We bring down the negative 8. 4x divided by x gives 4. So 4 times x gives 4x. 4 times negative 2 gives negative 8. When we subtract, so we subtract to give 0. So we've gotten the two factors. We can now factorize the second factor to give us the 3 factors. And by then we would have factorized completely. So h of x now will be x minus 2, which is the first factor. Then x squared plus 5x plus 4 is the second factor. So to factorize this quadratic expression, we are going to get x in bracket since we have x squared here and the coefficient is 1. So the two factors of positive 4, whose sum will give us positive 5, are plus 1 and plus 4. So with this, we have completely factorized the polynomial h of x. And that's the end of solution to problem 3. We go to problem 4. For problem 4, given the polynomials f of x is equal to x squared into x minus 2 and g of x is equal to 11x minus 12, find the values of x for which f of x is equal to g of x. We are going to equate, so let's go. Since f of x is x squared into x minus 2, so we keep it x squared into x minus 2. This is equal to g of x, which is 11x minus 12. So we expand this. This is x cubed minus 2x squared is equal to 11x minus 12. So we now form cubic equation from here. So we now have it as x cubed minus 2x squared. The 11x will come to the left hand side. I have minus 11x. The minus 12 coming to the left hand side becomes plus 12 equal to 0. So with this cubic equation, we first get a factor of this. We now use the factor theorem to complete the problem. So by inspection, if you put x is equal 1 minus 2 minus 11 plus 12, wow, that's giving us 0. So we put x is equal to 1. So wherever we see x, we put 1. So this is 1 minus 2, since 1 squared is 1 multiplied by negative 2 gives minus 2, then minus 11 plus 12. So this is going to give us negative 13, and this gives positive 13. So it is equal to 0. So with that, we say x minus 1 is a factor of the left hand side of the equation. That is a cubic equation. So we go on long division. So we have x3 minus 2x squared minus 11x plus 12 will be divided by x minus 1. X cubed minus x is x squared. So x squared times x gives x cubed. X squared times negative 1 gives minus x squared. We then subtract this minus this gives 0. Minus 2x squared plus x squared. Since minus times minus gives plus, that will give us a minus x squared. We then bring down the negative 11x. So negative x squared divided by x gives negative x. And negative x times x gives negative x squared. Negative x times negative 1 gives positive x. We then subtract this x squared gone. Minus 11x minus x gives negative 12x. Since negative times positive gives negative, so we bring down the 12. So we say negative 12x divided by x gives negative 12. So negative 12 times x gives negative 12x. Negative 12 times negative 1 gives plus 12. Subtracting this will give us a 0. So with this, we've gotten the second factor. We then go ahead to factorize the second factor so that our x minus 1 into x squared minus x minus 12 is equal to 0. We factorize this, so we have x minus 1. Since the coefficient of x squared is 1, so I have x in brackets. So we are looking for two factors of negative 12 whose sum will give us negative x. So the two factors are -4 and 3. So I have the -4 and +3. This is equal to 0, which means x minus 1 is equal to 0 and x is equal to 1. X minus 4 is equal to 0, x is equal to 4, x plus 3 is equal to 0, x is equal to -3. So these are the values of x for which f of x is equal to g of x. And we are done with solution to problem 4. This is the highest we can take in this tutorial. I hope you enjoyed it. Remember to like and share this video. Don't forget to subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on polynomials. Until we come your way again, goodbye.